Hallo allemaal. Ik ben erg blij om hier bij jou te zijn. Oorspronkelijk wilde ik mijn lezing in het Nederlands geven. Maar toen herinnerde ik me dat ik helemaal geen Nederlands sprak. And that's the reason why I'm going to speak in English. A day has only 24, more or less, 1 hour, and we have not more than 30 minutes to speak about that. We are going to discuss how to check the current time in Python, that you shouldn't check for the current time too often, and that you should check what your government does. My name is Miroslav Šedivý. I was born in Czechoslovakia, which you would initialize as the Europe-Bratislava time zone. Studied in France, which is the Paris time zone, and now I'm working in Karlsruhe in Germany, which is Berlin time zone. So many time zones, and still I spend the whole time in one Central European, sometimes summer time zone. But we are going to see why there are so many time zones behind that. I'm going to do some live coding, so please set your time clock to this exact time, because this is what all the following slides are going to use. So now we are 11:02 Central European Summer Time here in Groningen on Friday, 10th of May 2019. So if you want to check for the current time in Python, what you do, you import standard datetime library and then datetime now, and you get an object with the current time. This is wrong. Don't do that. Because if this is what you get on your computer, on a server that is set to UTC, you will get something different. A very similar object that doesn't distinguish itself, it distinguishes itself only in the hour parameter, and there is no information that it is UTC or the local time. So you will get two datetime objects that are similar, but different, offset by 2 hours now in summer. If you want to get the current time on both machines, the same current time, you can use datetime UTC now, which will return the current time in UTC without the information that it is UTC, but that's maybe enough. If you want to add the information that we are in the UTC, you use the standard Python 3 library datetime.timezone and the UTC attribute that will return on any machine the current time in UTC with the information that we are in the UTC. But if you want to get the current time here in Groningen, we have to give it the information that we are in a time zone that is 2 hours ahead of UTC, and then we will get the current time, 11 o'clock, with the information that we are 2 hours ahead of the UTC. But we are ahead of UTC, 2 hours ahead of UTC now in summer of 2019. Next year and in 2 years, it will be different. So we need the information that we are actually not 2 hours ahead of UTC. We want to tell that we are in Groningen or in the Amsterdam time zone. And that's why you have to use the third-party library pytz. And then you say, I want the current time. This is where you are going to use datetime now, but with the parameter that you are in the Amsterdam time zone. And this will return the current time with the information that you are in Amsterdam, and that datetime object, you can use it to convert everything and to keep the current time. If you want to do something like this, you want to get the today's date and the yesterday dates, you can do something like this. But this code will return wrong result in the time, at the moment when you are not at your office. Because if you start these 2 lines of codes 1 microsecond before midnight, today and yesterday will be the same day. Because the first line will get executed before midnight, the second line just after midnight, and after midnight minus 1 day is again the same day as yesterday. So you don't want to do this. You want to check your current time only once. So at one moment in your code, logical function, you just execute, you check the current time, for example, UTC now or now with the time zone, and then you calculate with this variable. Because it doesn't matter how fast your computer is, if the function is 1 microsecond or 2 hours, it doesn't matter, it uses the same time from the beginning. However, there is one exception when you want to check for the current time several times. For example, if you are measuring operation, some expensive operation like download from the internet. Then you check the current time at the beginning, at the end, and then you calculate the difference. Using datetime is also a little bit overhead because you don't need really the whole datetime object. What you can use is the standard time library, and time.time returns the current time in seconds since epoch, so some number of around 1.5 billion. And end would be 1.5 billion and maybe something more. And this way you can calculate the difference directly as a float in seconds. But this may return negative results. Imagine that during this expensive operation, NTP-date service runs, and it updates your system clock from the server. And if your local time on your computer, the system clock, is offset by a few seconds, it may happen that exactly in that moment, it will turn or roll the clock back by a few seconds, and you start, or end minus start will return a negative number. But fortunately, in Python 3, there is time monotonic, and this is a function that returns some float that is guaranteed to be incremented the whole time. So anything happens with your system clock during the expensive operation, time monotonic at the beginning will be lower than the time monotonic at the end. And if you are using Python 3.7, you have it even with the nanosecond time precision. So this was Python. Now let's get back to the time. How is time measured? If you want to measure time, maybe you can say, okay, we just look where is the sun. At noon, the highest position. Next day, the highest position. And then we divide the time in between by 24, and we get exact hour. That's wrong. Ever heard of equation of time? No, solar equation, I think. It's the fact that the sun and Earth, as they rotate, they don't, not every day they takes exactly 24 hours. It means that the sun's highest position at noon oscillates during a year by 15 minutes, plus or minus, here in Europe. It means that during the year, some days are a little bit longer, some are a little bit shorter. And this Greenwich mean time, this word mean, comes exactly from this, that we have a mean position of the sun during the year. And if you look at some solar clocks, you will see something that looks like an 8, a big 8. And this 8 tells exactly at which position of the year, how much offset of the sun, of the solar noon there is, comparing to our noon. And this oscillates by 15 minutes plus or minus. So at the beginning, of course, you lived in a city and you had your local solar time, plus minus 15 minutes. And there was no reason to check the time in some other place because traveling to a 50 kilometers to other city that is 50 kilometers from here, you just need it to walk the whole day or 2 days. And there was no reason just to know that they are a few minutes ahead or not. Over the time, there were some clocks, transportable clocks, that you could use to check, to know the current time here, and then come to another city and then tell, okay, the current time in Amsterdam is so much, and here in Berlin it's different. But the problem with this clock was that it was not possible to transport it very well. Imagine that in those times, even the calculated longitude on the sea was not possible because you couldn't have a good clock with you on the boat because the pendulum didn't work on a boat. Later, with railroad, there was a need for some common time, not for the passengers, but because on those simple single tracks, you didn't want to send 2 trains at the same time. So the countries, they adopted some central times. There was Greenwich, French, they had their own time. With railroad, France adopted common time, standard Paris time zone, which was standard Paris time plus 5 minutes. These 5 minutes were exactly for the passengers that were too late for the train. They just offered them 5 minutes extra to get to their train. And with the railroad network over Europe, there were more time zones that came on the world. What you see here is how I think that time zones in Europe should actually be and how they looked like 100 years ago, more or less, with the borders at that time. And yes, Netherlands should belong to the Greenwich time because Greenwich is 0 degrees, Prague is 15 degrees, and 7.5, which is the middle, runs actually around the border between Benelux, France, and Germany, Switzerland, and Italy. It was also like this before, but in 1940, Netherlands and France, occupied by Hitler, and Spain by Franco, who said, oh, Hitler with his Central European time is great, we are going to do the same. They changed their time. If you now want, as I mentioned, if you want to work something with time zones in Python, you have to import pytz. You can import anything else, but I will show you that all these convenient or less convenient libraries depend on one source that you should use anyway. You see, in pytz there are over 400 time zones, although we have Greenwich plus and minus 12 hours, so like 25 time zones. The reason is 440 time zones are 440 different places that had different time zones, daylight saving time introduction, abolition since 1970. What happened before, it was totally wild, but the pytz tries to reflect since 1970, and these are the time zones. So somewhere you see Netherlands. The colors are the same time now, and you see in summer in Europe we have the same time as Eastern Africa because we are with our summertime we are 1 hour ahead. If you want to remember or want to find where this comes from, this is IANA, organization that takes care of all the time zones. Is not a real authority, so they don't dictate anything. They just take the information and publish the TZ data library. So this library is published about 10 times a year. The current version, 2019A, is from March 2019. And if you download this file for free, 370 kilobytes, and you unpack it, it's a wonderful source of information of the history of the world of the past 130 years. You see some oak, shell, pearl files. There are programs to extract the information, but the most interesting are the files like Asia, Europe, Africa, North America, South America, and so on. And this is the interesting information. Europe, 170 kilobytes. There is some code in it that we are going to look at, and there are a lot of comments. And these comments is like a book. There is this IANA has a time zone mailing list where people just post the information about updates in the time zone, and there is discussion, a really very interesting discussion, and the most relevant information gets into this data file. So if we are going to look at some random time zone, okay, let's take Europe, Amsterdam. This is how it looks like. The first block is the information about Amsterdam. You see at the beginning there is 1932. This is the offset to UTC at the beginning, valid until 1835 and then 1937. This was the standard time in Amsterdam, 19 minutes and 32 seconds ahead of UTC. And then in 1937, they moved by a few seconds to be 20 minutes ahead of UTC. So until the World War II, Amsterdam was around 20 minutes ahead of UTC, so 40 minutes behind Central Europe, Germany, and Czechoslovakia, and other countries. And then after World War II, it changed into the Central European time, and the second column with this net, CEU, EU, and EU are the rules that are common for several countries. The bottom block, you see there is the information about the daylight saving time in 1916, 17, 18, 22, 23, and there is exactly the information when the daylight saving time started, when it stopped. Then there is a comment from 1926 through 39, daylight saving time began on the 5th of until the 15th, except if it was delayed by a week in years when it fell on the Pentecost weekend. So there were such rules. And you have to reflect all of this in this file, because every change in the history, if you want to calculate something that happened in the 30s, in Amsterdam time, and you want to convert it to German time, you have to use this, and this is all the information they get into it. If the European Union abolishes the daylight saving time in 2 years, this all has to be there, and even more, even the new information. And now, this is some Central European time zone during the World War I and World War II. And this is what is the most common now, is the rule for European Union. You see that in the 77, 80, it started. Actually, at the end of the 70s, there was a lot of chaos in Europe because every country started with a daylight saving time on a different day, different year. That's why Germany has 2 time zones. Both of them start with B. One is Berlin, another one is not Bonn, another one is Büsingen. It's a small village at the German-Swiss border. It's completely in Swiss, but next to the border, and they started with the daylight saving time in 1980 together with the Swiss, although Germany started already 1 year before. Who here remembers that the daylight saving time didn't end at the end of October, but at the end of September until 1995? Everything is there in the. You see the last line starts 1996. We start with the end of the daylight saving time in October, but before it was until September. If the European Union abolishes daylight saving time, there will be new entries in this file. If every country does it differently, some stay with the daylight saving time, some not, you will have new entries. Actually, it's summertime and standard time. It's not winter time. There was winter time once in one country, in Czechoslovakia, 1946. In November, 27th of November 1946, the government decided that from the 1st of December, we do even 1 hour, we go even 1 hour back. It lasted for 3 months, after abolished, never used again. But the Czech Republic and Slovak Republic, as they follow the laws from Czechoslovakia from before, are the governments, the Czech government, the Slovak government, they are now allowed to declare winter time at any time. The law is still valid. So if you want to take one picture with you, this is the most fascinating. This is the history of the world of the past 130 years. There are years from 1890 until the future, until 2038. The 0 is Greenwich. To the top is east. To the south, to the bottom is the west. So there is America, Europe with Africa, and Asia. And at the beginning, you see random lines. This is the local mean time in every city, so random minutes, random seconds. And then they started to go to the standard 24 hours. Some of them moved by offset by half an hour or a quarter of an hour. When you see something like this is daylight saving time. And if you see some vertical lines jumping like this, these are some islands in the Pacific that jumped 1 day. There is somewhere Netherlands with their 20 minutes offset, not so very visible here. But what you see, the current time, 2019, and the current information tells that we are going to follow the daylight saving time until 2038. If you develop an application, put it into Docker, and you say, okay, it's tested, it works perfectly well, and you keep it that way, and in 2 years, the European Union abolishes daylight saving time, this is what it's going to do, because it is programmed that until 2038, we are going to switch to daylight saving time. This is in Europe, so you see the places of the cities that are defined as time zones, and L is the position of Amsterdam. And this is the same picture just for Europe, and you see in the beginning the blue lines 20 minutes ahead of UTC, this is Amsterdam. At the top, the daylight saving times, this is Russia, yeah, and we are somewhere in the big group of all Central European countries. Amsterdam was interesting, but there are other countries in the world that are playing with the time zones even now. There is Istanbul. If you look at it in the 2011, 14, 15, there were some changes. There's some code, and there are also the comments. So Turkey will change into summertime on March 28th instead of March 27th. So on the 10th of March 2011, 3 weeks ahead, they decided we are not going to switch on Sunday, we are going to switch on Monday. This change is due to a nationwide exam. And there is some URL, some link to some Turkish newspaper. They didn't learn because 2014, there is Turkish local election, so they will move clocks forward 1 hour ahead on some other day. Again, decision a few weeks ahead. The second comment is from Randall Schwartz. Having landed on a flight from the States to Istanbul, I can tell you that nobody, even the airlines, respect this time zone daylight saving time change delay. Maybe the word just didn't get out in time. Maybe it did. But imagine all the embedded systems or the airports, they are not going to update their daylight saving time information just like that. 2015, okay, they are going to delay winter time to November even. And again, some links to some Turkish newspapers. This is interesting because in this mailing list of the TC data, they have to, there are discussions of people who just send them, oh, actually in the newspaper I read that the government is going to do something. And the link is maybe in English, maybe in Spanish, maybe in Turkish, maybe in Korean. And someone has to confirm that. And if there are enough people who confirm that, then they are going to introduce it into the system. This is 2007. You see there are some comments from 2016 and 17, but the code is just simple because there were some changes announced and then abolished. So actually in the code, it never happened that Turkey will stay in daylight saving time even in winter, but there was a discussion that it will happen since next year, and then they abolished it. So actually in the code there is nothing, but in the comments you see that Turkey just jumped all around the time zones. Caracas, Venezuela, clocks advance 30 minutes on the 1st of May, announced on the 15th of April, 2 weeks before, and then published in the official Gazette, and there is some Spanish URL. Port-au-Prince, this is Haiti. Haiti in summer has 13 hours of daylight, sunshine, and in winter 11. So they are so near to the equator, there is no real reason for daylight saving time. And still, every year, since several years, they decide in February or in March, are we going to start daylight saving time this year or not? So there's information like the last one. We have received 4 mails from different people telling that Haiti has started DST again today. And this source seems to confirm that. Seoul and Pyongyang, Korea. These are 2 time zones that were the same until 45. The local mean time in Seoul and in Pyongyang were, of course, different by a few minutes. And then they moved to 8 hours 30 ahead and then to 9 hours. And then in 1954, South Korea decided, oh, we are going to move to 8:30. They did it, except that airlines, naval authorities, and telecommunications and meteorology didn't do that. So 54 to 61, the whole South Korea was half an hour offset, but all authorities that were somehow international, they used the standard international time. And then in 61, they returned back, and since then, they are staying with 9 hours ahead. North Korea is something different. In 2015, according to many news sources, North Korea is going to change to the 8:30 time zone on August the 15th, 1 week ahead. The most important, of course, bells rang out midnight Friday as part of the celebrations. But it didn't get to the TZ data information fast enough, so people using Pyongyang time were not able to, on their computers, to see the time changes. 2018, North Korea revert its time zone again back to the Korea Standard Time on the 5th of May, announced 6 days before. And the last link, it appears to be the front page story at the top in the rightmost column. You open the PDF, there are about 10 columns, and somewhere in the corner you see some Korean text that tells that Korea is going to change the time. Actually, shortly after that, I tried to check the current time on my computer. I'm using Arch Linux. And since the pytz is not depending on TZ data, this is something you have to pay attention to, the Python and the shell time on the same computer, they show the different time in North Korea because the versions were not identical. You always have to pay attention. Your Python, pytz, if you use database, PostgreSQL, all of them should depend on TZ data, but you have to take care how they depend on that, whether you have the current version or not. So, what are the best practices? Don't invent your own time zones. Don't hard-code any rules. So, end of March, end of October or September, no. Keep your time zone libs up to date, which also means that keep track of which library version of TZ data you are using on which computer. Follow your government's intention to modify your time zone and inform EANA.org. If you write a nice comment about, oh, European Union is going to switch something, then your name can get to the TZ data archives and some future me will speak about you in this talk. And if you can, avoid the time zones. Thank you very much.
Thank you We have time for a number of questions. So if anybody has a question, please raise your hand. Have you gone insane yet? Sorry, wait a minute.
Oh, sorry. I'll repeat it. Have you gone insane yet? With all the time zones change, those kind of things like.
But I'm going to sing.
Insane? Have you gone crazy yet with all the changes?
The time zones are sometimes they can be useful. A few years ago, I got some data, some sensor data in Germany, and the author didn't know which time zone it is in. So it was useful to know that there are some time zones, and I could check just for the end of March, end of October, and to see whether there are some gaps in the data. So sometimes you have to see a lot of time zones.
Any other questions from the audience? In that case, well, as I said, the saying was that printing was the hardest problem in computer science, but I think time zones is a great contender in that case. Thanks for a great talk. I have a present to you. Oh. We're on tight schedule in this time zone, of course. Here you go. So a big hand, and thank you very much for your great talk.